Welcome, class. It's Dr. Lindner, and we are going to be covering different types of tissues. And I believe last week, when we did the introduction to anatomy and physiology, we kind of spoke about the concept of chemistry, right? We talked about chemicals coming together. And when chemicals come together, they make cells. And then when cells come together, they're going to make tissues. And when tissues come together, they make organs. And then when organs come together, they make systems. And we spoke about some of those systems last week, like digestive system, respiratory system, immune system, musculoskeletal system, cardiovascular system, integumentary system, right? We spoke about all these systems. And then the systems come together and they make the crowning creation of all the organism. So what we're going to be focusing on are the tissues. And I did introduce last week the four different types of tissues. There's epithelial tissue, there's connective tissue, there's neural tissue, and then there's muscle tissue. Now, of the four types of tissues, neural and muscle are the easiest. Okay. It's epithelium and connective. Of the two, I feel epithelium is easier, connective tissue a little bit more challenging, only because there are more subcategories. There's lots of subcategories under these two. Okay. So we're going to start with epithelium. Okay. So I'll start with epithelium. We'll spend maybe 15, 20 minutes or so on this topic, and then we'll pause, we'll come out, we'll talk about connective tissue for about 15, 20 minutes or so. Then we'll pause, see if there's any questions, okay? So we'll start with epithelia or epithelium. It's the same thing, okay? Now, when you hear epithelium or epithelia, this is the type of tissue that deals with lining and covering. It's a lining and covering type of tissue. So when I think of covering, when I think of what is it that covers the human body, I'm thinking about, okay, the outside of the body, the external surface of the body, which would be the skin. And when we do the skin, skin is dermis, epi is above. So when we talk about the skin we will talk about as epidermis, dermis, and then what's below the dermis is hypodermis. So the covering of the skin, the epidermis, is epithelial tissue. That's a covering. Lining. What we mean by lining is that epithelium is going to line the body cavities and the tubules. Well, body cavities we covered last week. We spoke about the cavity in which the heart is in. We talked about the cavity in which the lungs are stored in. We talked about the cavity in which the digestive organs are in. Okay. The tubules, when you look at the word tubules, we see the word tube. And a tube really is just like this. So anything that looks like this, whether it's blood vessels, whether it's an esophagus, whether it's a trachea, whether it's tubules within the kidney, like proximal and distal convoluted tubules. Anytime there's a tract or a tube or a hose-like structure within the body, it's safe to assume that they're going to be lined with epithelium. So blood vessels, the respiratory tract, the digestive tract, um, these tracts are made up of tubes or tubules. They're going to have epithelium. Okay. And glands are classified as epithelium because they develop from epithelium membranes. So glands like the mammary glands, the oil glands, your sweat glands, In the ear, ceruminous glands. So those type of glands are considered epithelium. Okay. Now, one of the things that I want to mention about epithelium is a lot of textbooks have you compare and contrast epithelium to connective tissue. And I know we haven't done connective tissue. We haven't, we just barely started epithelium. But I want to show you a difference under a microscope, okay, between epithelial tissue and connective tissue. When we look at epithelium, one of the unique qualities about epithelium is that it's made up of a bunch of cells that are closely packed together like this. These are a bunch of cells that are closely packed together. There's very, very little space between these cells. The space between the cells, it's referred to as extracellular matrix, ECM, extracellular matrix. So in your reading, you may have heard the word intra, and then there's extra, and these are opposites. Intra means within, and extra means without. So extracellular matrix is the substance between the cells. Intracellular matrix would be the stuff within the cells. So epithelium is a bunch of cells that are closely packed together, and it has very, very little extracellular matrix between them because they're like packed really, really close together. And, they could be squares, they could be cells that look like these tall columns. Again, these are closely packed together. They could be cells that are very, very irregular shaped, like this, a bunch of cells. And again, these are very closely packed together. You can see all these different nuclei with little extracellular matrix. So those characteristics, if you see a bunch of cells closely packed together with little extracellular matrix, we're going to call it epithelium. But if we see cells like this, and they all have nuclei, maybe they're different shaped nuclei, and the cells are far apart from each other, and there's different protein filaments and fibers, and there's lots, let's call it increased or lots of extracellular matrix, that's connective tissue, right? So there's a big difference if we contrast the two. Cells scattered far apart with lots of extracellular matrix, that's going to be connective tissue. Cells closely packed together with very little extracellular matrix, that's going to be epithelial tissue. Okay. Okay. When we look at epithelium, we need to ask ourselves three questions. Okay. This is going to be question 2, and this is going to be question 3. So we have to ask ourselves, well, what the heck is question 1? Question 1 is we're going to refer to it as epithelium if we have to ask ourselves this question. Are the cells closely packed together, or are the cells far apart from one another? Does it have little extracellular matrix, or does it have a lot of extracellular matrix? If they're closely packed together and there's little extracellular matrix, little space between them, it is safe to assume we're looking at epithelium. So that's the first question. The second question we got to ask ourselves is when we look at it, do we see one cell layer, or do we see more than one cell layer? So if we look at these are closely packed together, we know it's epithelium, and it's one layer thick. But these could be closely packed together, and now what do we have? We have more than one layer. So if it is one and only one cell layer thick, we refer to it as simple epithelium. But if we have more than one, if we have 2 or more, we're going to refer to it as stratified epithelium. Okay. And we always determine whether it's one layer or multiple layers because we start looking at it from the top, which is the apical layer. So whatever it is we're looking at, if we were looking at, let's say, this is the top of the skin, whatever is happening immediately under it, if we see one cell layer thick, then it's going to be simple. But if we see multiple, whatever's close to the top, to the apical surface, now we'll call it stratified. Okay, so far so good. So first question we ask, do we see a bunch of cells closely packed together or don't we? If they're closely packed together and it's little extracellular matrix, we're going to call it epithelium. If we see that it's one cell layer thick, it's simple epithelium. If it's more than one cell layer, it's stratified. That's the difference between simple and stratified. The third question, what is the shape of these cells? Are they flat and irregular shaped? Do they look like ice cubes or squares? Or do they look like tall buildings and columns? Right? Those are the three that I actually drew up here too, right? I drew one, two, three different types. These are ice cube, these are cuboidal, these are flat, irregular shape, these are squamous, and these are the tall columns, so we call them columnar, right? So we have three basic shapes of cells. So when we move, oh, let me just go here real quick. So now when we look at squamous cells, they could be one cell layer of flat, irregular shaped, or they could be multiple layers. So if it's one cell layer, it's simple because they're flattened like pancakes, they're squamous, so simple squamous epithelium. If we see multiple layers, then it's stratified squamous epithelium. Cuboidal, we're looking at these ice cubes, they're squares, and it's one cell layer thick, so it's simple cuboidal epithelium. When we see multiple of the squares, it's stratified cuboidal epithelium. When we see the tall columns, those are columnar. When it's one cell layer thick, it's simple columnar. When we see more than one, it's stratified columnar epithelium, right? So those are the three different shapes, squamous, cuboidal, and columnar. Let me just go back here. Sometimes the cells have extensions off of it. Sometimes they have cilia, and sometimes they have microvilli. Cilia are bigger than microvilli. Okay. Cilia are these long, slender extensions that come off the membrane of the cell, and it helps to move secretions and fluids across the surface membrane. So we may have something that looks like this, and it has these cilia, and maybe we'll have another one here, and it has these cilia, and maybe we have another one here, and it has cilia. And maybe, just maybe, this is the inside. Let's put another one here with cilia. And let's put another one here with cilia. And another one here with cilia. Now, maybe this is a cross section. This is a tubule. This is something is moving within the inside of this, right? Just think of it as this cross section like that. So something's moving inside of it. Maybe this is a woman's uterine tube or fallopian tube. And maybe she just ovulated and there's an egg here. And it wants to move the egg, maybe towards the uterus. So the cilia beat rhythmically, they move like the wind blowing the leaves on a tree, right? They just move and it can mobilize the egg maybe in this direction. So it can move things, even secretions. All right, let's say we move this way. Let's just change the orientation of this. Let's do this. Make a bunch of these columnar cells. And we'll make another one on this side. These are columnar cells. They're just sideways, doesn't matter. And there's going to be nuclei here. And then we'll make a bunch of cilia, okay? Now let's say this is the trachea. Let's just say this is the windpipe. So air is coming down through here to make it to your lungs. Now we have these, I'll make this green. We have these cells that also hang out in here. I'll make them green. We'll call these goblet cells. We'll call these green ones goblet cells. And what goblet cells do is they make mucus. So these goblet cells are going to secrete and produce this mucus that's going to stick to the top of the cilia. And these goblet cells also are going to make mucus. It's going to move to the top, and it's going to create this sticky substance here. And that's important because as you breathe in, you're going to breathe dust, you're going to bring particles, you're going to be breathing smoke, things and foreign filaments from the outside, and toxins and debris can come in, and we don't want it making it into your lungs. So thank goodness we have this mucus here, and all the debris and dust can stick to the sticky substance. Okay, and what's happening is these cilia are beating upwards, right? They don't beat down. If it's beating downwards, it's going to drive the debris to the lungs. So it's beating upwards, so that all you have to do is, if there's dust or debris, all you have to do is this. You give a little cough, and it forces it, moves it up. That's pretty cool. That's what cilia do. Now, in smokers, however, if you're a smoker or you know someone that smoke, that paralyzes the cilia. It paralyzes them and burns them off. So now you don't have mucus sticking to anything. And when these cells alter in shape, these were columnar, these were ciliated columnar cells. When smoke comes in and it damages and paralyzes the cells, when one cell changes its shape and becomes something else, it kind of makes like a metamorphosis, and it changes. There's a term for that called metaplasia. Metaplasia is when one cell, these columnar cells, for example, change shape and then become squamous cells. And squamous cells don't have cilia. And if you've ever heard of squamous cell carcinoma, that's throat cancer. So when people smoke and these cilia burn off, and they smoke and they smoke, now you get all these carcinogens and cancer causing agents making it deep into the lung. And now the person doesn't have the cilia. This is when they wake up in the morning with smoker's cough. You hear them, right? They try and force the tar and all that substance, from pushing it, to try and push it up and out. And if you had cilia, because they were healthy, you wouldn't have to work that hard. You just go and you clear your throat. So there's an important reason why we're learning all this stuff, right? It's not just memorizing what epithelial tissue is for the sake of it. It's to help us understand. If you know what normal structure is, then you can start to understand abnormal structure. And if you have good structure, you have good function. And if you have bad structure, you have malfunction. And malfunction is what we call disease. Okay. Now, what's smaller than cilia are microvilli. You may have cells like in your intestines that look like this, and you may have very, very small, much smaller microvilli like this. And when you eat food and food particles start moving through the intestines, and your digestive enzymes break down these particles, they get absorbed. They get absorbed in by these microvilli. They're used to increase absorption. And in the intestines, we're going to have arteries in here. You're going to have arteries to absorb the nutrients. As it comes in, The proteins come in, the carbohydrates come in, the fats come in, right? Everything comes in, and your body's going to break them down, absorb it, bring it into circulation for energy and to help rebuild all the other tissues of the body. So cilia and microvilli are important. We have cilia in our respiratory tract. We have microvilli in the digestive tract. Really important stuff, okay? So there was one other type of cell that I wanted to show you, and it's called pseudo stratified. Now, if you look at the term, pseudo means false. Pseudo means false. So pseudo-stratified columnar. Well, these are definitely columnar cells, right? They're definitely columns, so they're columnar. But if you look at these are columnar, but look at the level of the nuclei, right? They're all at the same level. So it's easy to tell whether it's one cell layer or multiple. In this one, it's one cell layer thick, but if you look at the level of the nuclei, they're at multiple levels, so it gives it the appearance that it's stratified at a first glance, but it's really not. So it's called pseudo stratified columnar. And you can see that you have cilia here. You can see that we have cilia here. So there's lots of these cilia in the respiratory tract. Okay, and then remember, we have those other cells called goblet cells, and those goblet cells produce mucus, and it releases the mucus to the top, and you get this sticky substance here. So as the cilia are beating rhythmically in whatever direction they're beating, whatever it's moving moves with it in the same direction. Okay? So when you take a glance at this is one cell layer thick from the side, simple squamous, they're flat, irregular shaped. This is simple cuboidal, and this is simple columnar. All the nuclei are at the same level. This is the top or the apical surface. So when we look at the apical surface, if we look at the top portion of it, it's a few layers of those pancakes. So it's stratified squamous. Here, it's more than one layer of cubes, so stratified cuboidal. This is stratified squamous. And now here, these are columnar, and the nuclei are at different levels, but it's still one cell layer thick, so it's pseudo stratified columnar. Okay, and I'll throw one more in the mix for you called transitional. Transitional is pretty easy. If let's say this was a balloon, let's say that was a balloon, and you let's say we put the letter, let's say I put a square on this with a dot, and it's deflated. You could see the square. But if you start blowing this up and pushing air into the balloon and the balloon stretches and expands, think of what happens to the square. It changes in shape. It goes through a transition. So in body parts that we have organs that can alter in size, think of the urinary bladder, that if it's empty because you went to the bathroom, compared to holding urine all day if it's fully distended, right? So depending on whether it's inflated or deflated, like the balloon, the cells can alter in shape. So anywhere in the urinary tract, you're going to have transitional cells. So this has shown up in the past on some of the Connect quizzes, and it was like a drag and drop, right? So you can see we got simple squamous, simple cuboidal, and they give you a definition in terms of function. Now, if we have something that's flat and irregular, like this, right? Flat and irregular, like the pancake, it's very easy for substances to diffuse and to pass through. It's like a membrane. It could pass through. So we call that diffusion. It's good for filtration as well. Just think of like a coffee filter, right? It's one cell layer. You can put coffee grinds in there and then it passes through the Mr. Coffee machine, whatever it is, and you get a cup of coffee. So simple squamous epithelium can function in diffusion and filtration and even secretion. Simple squamous, this is great for maybe oxygen to pass through or for carbon dioxide to pass through. So in terms of um, diffusion, you can have water diffusing through here. You can have elements. We can even have gases that diffuse. If it's one cell layer thick, it's easy, simple squamous. Now, simple cuboidal, these are found in parts of the kidney, good for absorption, secretion, and protection. Simple cuboidal epithelium is typically found in the proximal convoluted tubule and the distal convoluted tubule. And again, the proximal convoluted tubule and distal convoluted tubule, they're part of the kidney, which I know we haven't done yet. And the part of the kidney that will find these structures is called the nephron. The nephron is the functional unit of the kidney. That's where we find simple cuboidal epithelium in that part of the kidney. Now, let's say we have these simple squamous, and now we're adding a few layers to it. Now, if you add a few layers to that, it's a lot harder for things to passively diffuse. So it's more for like protection. So stratified squamous, I'm thinking about the skin, right? The top layer of the skin. If your top layer of your skin was one layer of simple squamous and you scratched yourself with like your nails, you'd bleed. You'd peel away the one layer with a simple scratch. But thank goodness you have like 20 to 30 layers of stratified squamous cells. Okay. Pseudo-stratified columnar, pseudo, false, that functions in the movement of secretions like mucus across the apical surface. Okay, that's what we were talking about here. That's what we were talking about in the trachea with the goblet cells producing mucus, right? So that's found in pseudo stratified columnar epithelium. Okay? It can move secretions like mucus across the apical surface, that's the top surface. And transitional, right? Transition, that was the balloon that I drew before, right? This thing here, that accommodates distension and relaxation of an organ. So we think urinary bladder with the transitional epithelium. Okay, so to review, right, we have simple epithelium, one cell layer thick, stratified epithelium, two or more. We have squamous, cuboidal, and columnar. Those are the shapes. The squamous are irregular, flat pancakes, good for protection, secretion, and diffusion. I'm thinking the lungs for that. Cuboidal, the cubes, I said they're found in the kidney, the part of the nephron, the tubules, the proximal convoluted tubules, and the distal convoluted tubules. Remember we said that epithelium is lining and it can line tubules. So proximal convoluted tubule and distal convoluted tubules are going to have cuboidal cells, good for secretion and absorption. And then we have columnar cells. Those are the column shaped. We're going to see those in the respiratory tract, and we'll see them in the digestive tract. Pseudo, we said false. That's because the nuclei lie at multiple levels. They're at different levels, but it gives a false appearance of being stratified. And typically, when you have pseudo stratified, right, if you have that, you're going to have the cilia. They're often ciliated. And transitional, it is a type of stratified squamous, but depending on whether the organ is full or whether it's empty, it can alter in shape and goes through a transition. So we think anywhere in that urinary tract, urinary bladder, ureters, parts of the urethra, these are all parts of the urinary tract. So we'll finish up epithelium with just reviewing where could we find some of these. Well, the pseudo-stratified, right? If you look here, these are pseudo-stratified. We could see cilia. Those are found in the respiratory tract. And oftentimes, remember, we have these goblet cells. The goblet cells produce mucus. That's the sticky substance that can adhere to this. So pseudostratified, ciliated, we think respiratory tract. When we think stratified squamous, right, here's the apical surface. So these top layer, these are the pancakes. We need this for protection. So I'm thinking skin, like the epidermis, and also the beginning of the digestive tract where the esophagus is, right in here. Because imagine you swallow something like a Dorito or a cracker that has a sharp corner to it, it can scratch this. So you have multiple layers of protection against heat, sharp objects that you may swallow, it protects it. Okay. Now we can have simple columnar. Simple columnar, that's different than pseudostratified columnar. These are simple columnar. These are found in the intestines. And oftentimes these can have cilia and microvilli because in the intestines, we're going to absorb nutrients. We can absorb nutrients. Simple cuboidal, these are in the nephron of the kidney. And this is when we have the proximal convoluted tubules and the distal convoluted tubules of the kidney. So here's the lumen, right? This is where urine is going to be traveling through. So we have one cell layer thick of these cuboidal cells, so it's simple cuboidal. Here it's flat pancakes. But it's one cell layer thick, so it's simple squamous compared to this one here, which was stratified squamous. So when it's one cell layer thick, this is where you can have things like oxygen or carbon dioxide that can passively diffuse through here. So the air sacs of the lung can have simple squamous epithelium. And this is like really important stuff because there's some really neat cutting edge information these days about rheumatoid arthritis. When people have these inflamed joints with rheumatoid arthritis, and although it's very easy to think that it's a joint problem, there's a lot of cutting edge information that says it starts in the intestines, that there's damage to the epithelial lining within the intestines. And what holds cells together are tight junctions. So what's holding this cell to this cell is a tight union, a tight junction. What's holding this cell to this cell is a tight junction or union. Now there are things that damage those tight junctions. So let's say the person drinks alcohol and they have high sugar, fried foods, plus stress, too much coffee. It damages the junction, it damages the tight junctions, and now you get these spaces between the cells. They're not tight anymore, they become leaky, and things can pass through. So if you have a large protein here that needs to be broken down by your digestive enzymes, but now this protein is small enough to pass through that leak, that permeable membrane, and it enters your circulation, it enters your blood vessels. Now you have a protein that entered the body before it was even broken down. And the body goes, hey, what is that foreign protein that's in the circulation, in the circulatory system? So your body produces these antibodies. And it produces these antibodies that are attacking this protein. And it's very likely that the vibration of this protein resembles the protein of cartilage. Then this protein in the food breaks down, and now your cartilage breaks down at the same time. That's arthritis, rheumatoid arthritis. If the protein vibration of this protein passes through, gets into your circulation, and the vibration of this protein resembles that of the thyroid, then it starts to attack the thyroid gland. And now you get like a Hashimoto's. Okay. So they call it intestinal permeability or leaky gut syndrome, and it revs up the immune system and it starts to attack the food and anything that looks like the food. And your body is made up of a lot of protein. So just think about like walking and you're at the mall and you see someone from behind and you tap them on the shoulder and they turn around and you go, "Oh, I'm sorry, I thought you were someone else. You look like them." That's what happens with these antibodies. It kind of attacks anything that resembles that protein. So that's a great way of looking at rheumatoid arthritis is what I do with my patients that have it. We work on healing up the intestines, working on healing the gut and removing anything that can insult it from their nutrition. Good place to take our first break. See if there's any questions. When we come back, we'll talk about connectivity.